conservation of momentum problem. Here we go. We have a block sitting at rest on a frictionless surface. A bullet is moving toward it. The bullet has a mass of 10 grams. It's flying at 300 meters per second. It's going to pass right through this block of 1.2 kilograms. And when it emerges on the other side, the bullet no longer has a speed of 300 meters per second, but a speed of 80 meters per second. And the question is, well, what's the velocity of the block? Well, this is some kind of a collision. And every time you have collisions, you need to think momentum. Okay, that's important. Collisions mean momentum. And every time we have the situation here, you have to think the momentum before will be equal to the momentum after. Usually we see it written as the sum of the momentum initially equals the sum of the momenta final. So here we have, we'll call it the M1V1, we'll call that the bullet, plus M2V2, we'll call that the block. You know, I should change colors for those. We'll call this the bullet, and this the block. That will equal, afterwards, M1V1 prime, the bullet's new speed, plus M2V2 prime. That'll be the block's new speed. Okay, so that's the bullet and the block. So there's our equation. What we're going to do, we're going to plug everything in, see what happens, but the momentum before equals momentum after. The sum of the momentum, mv, right? Momentum is mv, where momentum's a vector, velocity is a vector. Those are important ideas. So let's see. First thing we have to convert. Darn it, they gave us this in grams. So ignore that. 1,000 grams is 1 kilogram. So 10 grams, we have to go from grams to 10 grams is how many kilograms? Well, there are 1,000 grams in a kilogram. So divide by 1,000, we get 0.01 kilograms multiplied by 300 meters per second. That's all to the right, so I'm going to leave that as positive. Remember, they're vectors, so direction counts. Plus M2, which is 1.2 kilograms. This one is at rest, so that's 0. So that's nice and easy. We get 3 kilogram meters per second. And it's positive because it's to the right. Plus 0. That's the momentum before. So the momentum after has got a sum to be 3 kilogram meters per second to the right. The momentum after is going to be the mass of the bullet. That doesn't change. The bullet's new speed is 80 meters per second. Again, to the right, so we keep it as positive. Well, that becomes 0.8 kilogram meters per second, plus the mass of the block, 1.2 kilograms times its new speed. This is our real unknown. So this is pretty much what we have. We've got 3 kilogram meters per second equals 0.8 kilogram meters per second plus 1.2 kilograms times V2 prime. Bringing this over there, subtracting 0.8 from each side, we're going to get 2.2 kilogram meters per second equals 1.2 kilograms times V2 prime. Divide both sides by 1.2 kilograms multiply this by 1.2 kilograms, and we're going to get 1.83 meters per second equals v2 prime. The new speed of the block is that. Now, does that solve all of our problems? Determine the velocity of the block immediately after it merges. We've got that, 1.83 meters per second. But now, is this an example of an elastic or an inelastic collision? Defend your answer. For that, we need to talk about kinetic energy. The types of collisions. In a elastic collision, kinetic energy is conserved. In an inelastic collision, kinetic energy is not conserved. So we have to find out about the kinetic energy before. Is the kinetic energy initial equal to the kinetic energy final? That's what this is going to be. And this is how we're going to defend our answer. Let's see. Kinetic energy before. Well, so this block has no kinetic energy, so that's 0. Kinetic energy before is just going to be the bullet. So 1/2 mv squared. 1/2 0.01 kilograms times 300 meters per second squared. 300 squared is 90,000 times 0.01 is 900 times 0.5 is 450 joules. That's the kinetic energy before. Does that equal the kinetic energy after? Well, let's look at the kinetic energy after. The bullet has 1/2 kilograms times the speed of the bullet is 80 meters per second. Square that. So the bullet has 80 squared equals 6,400 times 0.01 times 0.5. That's 32 joules. And then the block is 1/2. The mass of the block was 1.2 kilograms. And the speed of the block was 1.83 meters per second squared. Let's see what we got there. 1.83 squared equals 3.3 something or another multiplied by 1.2 equals that times 1/2 is about 2 joules. And they do not equate. 450 joules is not equal to 34 joules, not even close. This is not at all an elastic collision. This is very much an inelastic collision. In elastic collision, why? Because kinetic energy is not conserved.